Hey guys, welcome to today's lesson. Today we're looking at factorising by grouping the pairs. Now, it might sound like a bit of a strange heading, but certainly this is going to assist us in our next level when we start having to factorise the quadratic trinomials. Now, I'm going to start by looking at this question, x squared plus 3x, because certainly this question on its own, we've done this quite a few times now. In fact, we've already done this in year 9, did it in year 8, we did it in year 7. And that's where we take out the common factor and we factorise it just like that. Now, sometimes I could even write this expression slightly different. I could write it like this, x times x. Now, it's not a point x, it's a times. It's senior level mathematical times. And then I've got 3 times x. So what we're actually doing here, we're saying we've got an x that sits in both of these, okay? So because they're common, we can take it out the front, which is what I've done there. And then whatever is left, I've basically said goes in that second set of brackets, because what I'm saying is that both those terms have been multiplied by the x. Now, that's pretty easy. We've done that before. But if we look at example 1, it looks quite strange, and you're going to want to try and probably expand the brackets first of all, but you need to refrain, because if we expand the brackets, this is what happens. We had x squared plus 3x. We get plus 2x plus 6. You end up with x squared plus 5x plus 6, and you get stuck because you can't go any further, and you now have to factorize. This thing is what I'm talking about being a quadratic trinomial. Now, in fact, you're going further away from the answer. In fact, next lesson, what we're going to be doing is we're going to be given that as the starting point, and we actually have to travel all the way back. And so we do that by putting it into, or we say grouping the pairs and then factorizing. So what we're looking for, and we go back to that original example, is what goes into both of these terms. Now, if I look at these two things here, what you might recognize is both terms have this x plus 3. Now that's important, because just like the question above, we had the two x's, they are common, which means we can take that term out the front. You know, unlike the first example, that was just an x on its own. Now we have an x plus 3. And whatever is left, in this case, the x plus 2, goes into our second set of brackets. So if I look at that now, and I expand the brackets, we get x times x, which is x squared. We get x times 2, which is 2x. I get 3 times x, which is 3x. And I get 3 times 2, which is 6. And if we look over here, bang, that's almost identical, isn't it? So it works. So this is something we need to look at, where we need to factorize by grouping the pairs. Sometimes they've already kind of factorized up for us, and then it's just a nice simple matter of saying, hey, they're both the same, so let's put it out the front, and then whatever's left over, let's put that in the second set of brackets. The problem is with example 2 and 3 is, of course, that it hasn't been factorized initially for me. But what you'll recognize here in example 2 is that you have 4 terms that can be broken into 2 halves, but there's common factors in both of those. So if I look for the common factor in the first set of brackets, you will notice that x goes into both. If I factorize the second set of brackets, you'll notice that a goes into both. Now, when I do that, what have you noticed about your 2 brackets? This is what I talk about, the warm fuzzy feeling, okay? If you've done this right, for the most part, what's going to happen, just like that previous question, those brackets there should be identical, because if they're identical, we can then factorize that out of our expression. And I take that out, and then whatever is left over, and of course in yellow there you can see we have an x and a plus a, they go into that second set of brackets exactly like that, and we've got our answer. So this is really important, okay, that we want to try to break it into those pairs by factorizing the first length, and then we are going to factorize fully after that. Now, the next one, exactly the same thing. We have 4 terms here. I'm going to factorize the first 2. I've got 2x outside of x plus 3. What goes in the last one? Well, in this instance, there's nothing apart from 1. And usually it doesn't help us, because if I do that, we simply have the x plus 3 there. Nothing's changed. But what you will notice again is that the brackets are exactly the same, and that's what we want. That's what we're kind of working towards, because now we can factorize that out the front, and whatever is left over goes in that second set of brackets. In this case, it's the 2x plus 1. Now, of course, what you could have had was 2x plus 1 at the front of x plus 3, and they are exactly the same. There's no real need, or doesn't matter which way they are. If I break it down to things like what's 5 times 3 equal 2, and what's 3 times 5 equals 2, well, they're both the same value. So it doesn't matter which way we times those together, just making sure they're being timesed. And that's pretty much it for factorization and grouping of pairs. Now, of course, most of your questions are going to be breaking down those 4 things, which we're then going to factorize and put back into brackets. But example 4, which is start, is pretty much what we're doing next lesson. That's starting to get you into that really hard stuff of the quadratic trinomials. Because if you look at example 4, it's quite different to example 2 and 3, because you only have 3 things. You don't have the 4 things anymore, and that makes it really tough. So what we have to do when we get to these quadratic trinomials, again, it's called a trinomial because there are 3 things. It's quadratic because it's an x squared. We have to try and break this 3x down into 2 numbers. For example, we could do something like, let's say 2x plus x, because that makes 3x, right? We could do something like x squared plus 4x minus 1x. There's probably quite a few things that we could do there in order to make that happen. The issue is going to be we need to work out which one is the one that we want, and that's what next lesson will be. Now, if I look at this, I know that this one is the one that I'm going to look at, because if I factorize this, I get x plus 4. If I take a minus 1 out, I have x plus 4. I get the warm fuzzies because those brackets are the same. So I have x plus 4 at the front, and I have the x minus 1 inside the brackets, and it works out nicely. Whereas had I looked at that first one here, x goes outside of x plus 2, and 1 goes outside of x minus 4. Do you see the problem with that one? The brackets are not the same. We can't do anything with it. So next lesson, we're working on these quadratic trinomials, and we'll teach you really well how to figure out what these 2 numbers are that makes that middle number. But for today's lesson, I really want you to focus on the questions that I've set for you. I want you to work on these grouping the pairs, or factorization by grouping the pairs. They've already been sort of put as 2 pairs for you already. Work on those questions, and any problems, of course, let me know, and then we'll work into the harder trinomials next lesson. Have a wonderful day, guys.